Hello, guys. Welcome to Remta Solutions. Welcome to your exam prep on forces. Of course, this is a topic for grade 11 and grade 12 physical sciences. So, today the question paper that you're looking at is the Physical Sciences paper 1 from the Northern Cape that was written in September 2024. So, without any waste of time, let's do the normal read instructions. We are not going to read all of them. We are going to select a few that we are going to use in this series. So, instruction number 8 says, sorry, oh, show all homework, show all formulae and substitutions in all calculations. And then instruction number 9, round off your final numerical answers to a minimum of 2 decimal places. A further tip on this one is this. In the middle of your calculations, maybe work with about 4 to 5 decimal places and then only leave your final numerical answers to 2 decimal places. Pay attention, they said minimum of 2. Okay? Now, instruction 10 says give brief motivations, discussions, and so on where required. Remember, this is to say structure your motivations. Don't just touch on a point, go to another, come back, and so on. Okay? Touch a point, conclude whatever that you want to convey, and then move on to another if you have to. Okay? And instruction 11, you are advised to use the attached data sheets. In case of you forgetting your formulas or your constants, please refer to your data sheets. But of course, it is important. However, I always urge students to do this. I want you to do this before you get to your exams. Make sure you know your formulas. I know, knowing your formulas means you know your work. You know what you need to do to solve your problems. All right. But of course, it happens that you forget the formulas. So if you do, you have your data sheets. Okay. All right. This section is normally question 2. So let's see what this one was about. This one says we must finish it in 12 minutes time. Okay, it says we must finish it in 12 minutes time. So combined, we must be done at about 15 minutes in 15 minutes time we should be done. So let's start. 2 blocks of masses 9 kilogram and 4 kilograms are connected by a light inextensible string. A constant force F acting at 75 degrees to the horizontal is applied to the 9 kilogram block as shown in the diagram below. I can see that. The string runs over a frictionless pulley. Okay. The 9 kilogram block moves at a constant velocity of 4 meters per second while experiencing a frictional force of 2.5 newtons. Guys, I want you to notice this. The 9 kilogram block is moving to the left. So if it's moving to the left, it means friction must be going to the right. Okay? This is something I want you to see before you can do anything here. So now 2.1, so 2.1, let's see now. Black 2.1, it says, right, state Newton's first law of motion. This is the one that says an object remains at rest or uniform motion unless acted upon by a non-zero net force. Okay, so let's just do that. An object, let me just say continues or remains at rest, it's up to you. At rest or in uniform motion. In uniform motion or in uniform velocity unless acted upon by a non-zero net force. Right? Unless acted upon by a non-zero net force, isn't it? Perfect. 2.2, draw a free body diagram, a labeled free body diagram for the 9 kilogram block. So the 9 kilogram block, here is it, free body diagram. 9 kilogram experiences a normal force, experiences a gravitational force. It experiences friction that goes to the right. It experiences a tension that goes to the right. And then there is an applied force F that is 75 degrees to the horizontal. All right, that is 75 degrees to the horizontal. This is the free body diagram for the 9 kilogram block. Okay, perfect. 2.3, calculate, highlight this, the magnitude of the force acting on the 9 kilogram block. Let's perhaps begin by saying F net equals, or F sub net equals MA. Okay, so horizontally, so in the horizontal, no, let's not begin with the horizontal. We will have something unknown. Let's begin with the 4 kilogram block. Let's begin with the 4 kilogram block. For the 4 kilogram block, we will have tension minus mg is equal to, again, ma. What is the tension? We do not know. The mass of the 4 kilogram is 4. Of course, gravitational acceleration is 9.8. The mass is 4. And they said these guys are moving at constant velocity of 4. Constant velocity would mean acceleration is 0. Okay, it would mean acceleration is 0. So tension minus 36 2 point whatever, so it must be 39.2. So let me see, 4 times 9.8, 39.2. 39.2 equals 0. So our tension is 39.2 newtons. Okay. Now for the, I'm gonna move to the 6 kilogram block. So for the 6 kilogram, is it 6 or 9? For the 9 kilogram block. So for the 9 kilogram block, we have the free body diagram. All right, we drew the free body diagram. Now there's something that I want you to see. Concerning the force, the applied force, it was in this direction. It means the horizontal component, the vertical component, and the horizontal are like this. So the horizontal component is going down, so the vertical is going down, and the horizontal is going to the left. Okay, the horizontal is going to the left. Okay, so this is what? 75. Okay, this is 75. Okay, perfect. So here, what do we say? We will say tension is going to the right, friction is going to the right, minus f of x, or f sub x, and mass times acceleration. What is the tension? You said it was 39.2. What is the friction? It's giving us 2.5, as you can see. And from the free body diagram we drew at 2.2, we can see that it is going to the right. So it is in the same direction as the tension. And then this guy here, from this information, you can see that in order for us to get him, we can say cos 75 degrees equals f sub x over f. Therefore, f sub x must be f cos 75 degrees, isn't it? Perfect. Now, this is minus what is, we do not know what f is, so it's f cos 75 degrees equals 9 times 0, because the acceleration is 0, because the velocity is constant. Okay, so let's see. 39.2 plus 2.5. Okay, this is 41.7. 41.7 minus, I think I should leave it like this. Minus f cos 75 degrees equals 0. So f will be 41,7 divided by cos 75 divided by cos 75. So the force is 161.12 newtons. They said they want the magnitude. So we're going to leave it here and say this is 161.12 newtons. Okay. And this is how you answer this question. So as you can see, even with our yada yadding, we were able to finish it in less than 12 minutes. Our 12 marks is in the pocket now. So remember guys, if you would like to get in touch with us, in the description of this video, there are links that you can use. You can follow us on WhatsApp. We have a WhatsApp channel. You can obviously follow us on YouTube, subscribe, and even your social media platforms. And if you're looking for a tutor, you can also talk to us in whatever platform that you have. Okay. So having said that, ours ends here, and all the best. Bye bye.